Speaking up loud. I don't speak like this in the office, do I?
No.
Right. Speak up. Speak up as if you're shouting.
So basically, this is how like the structure of a rail track is. And then as you can see, there's a ballast, a rail, a sleeper, clip, chair, fish plate, all that kind of stuff.
Okay.
Right. Stop there, because that's interesting, isn't it?
Yeah.
Do me a favour, Reece. Can you just go up to the screen? Okay, we don't normally do this. Go up to the screen and point to things and tell us what they are, because we really can't read the words from here.
Mm-hmm.
So what are we? Tell us what's on that picture.
Alright, so this bit here is like a little corner that goes like that.
Speak up.
So this bit here, that's like going that to that. That's like a pad.
A pad,
It's like,
yeah.
Yeah, it's like going inwards as well, like in
So
the middle.
The
Yeah.
pad, is that constructed in what material? Is that concrete
It'll be
or
constructed.
metal?
Yeah, it'll be metal. It'll be either iron or steel.
Okay.
Yeah, and then there's.
It's actually a piece of metal, okay, with holes drilled in it, okay, and then you put a bolt through it, it's called a rag bolt, R-A-G, and you put it through, screw it, and it goes either into, what are those brown things? We don't know what they are. What's those brown things? Yeah, those two long brown things.
Yeah,
what are they?
Those are sleepers.
Sleepers. Okay.
Yes. Those are called sleepers. They help support the rails, like the tracks.
Okay. What are those sleepers made of?
Well, these ones are made of wood, but for more modern rails, they now use steel. They use steel now for more modern rails.
So you get steel sleepers as well?
Yeah.
Concrete.
No steel.
Is it?
No steel. Concrete.
Reinforced concrete.
It's on the page that they use steel and concrete.
Reinforced. It's
Yeah.
concrete reinforced. Reinforcement is the steel inside the concrete.
Yeah.
So you first form the steel and then you pour concrete into it to make it to reinforce it. So it becomes reinforced concrete.
All right. So what we have there then is we have two wooden sleepers, yeah,
Yeah.
and then you've got what are those long things there? The long grey things.
Well,
Yeah. What's that long grey thing?
That's the chair and clip.
Chair. Okay. And is that a rail?
This thing like going across there, that's the rail.
Right. So the rail sits inside the chair. Yeah.
Yeah.
And then the chair is bolted with rag bolts
Yeah.
onto the wooden sleeper. Yes.
Yeah. And
Okay.
and then they also I think there's also a bit onto the side of the rail there, onto the pad. That it gets bolted into as well to like help keep the sleeper and rail stuck together.
Right. So, go on.
I was going to ask them
Yeah.
from a construction point of view, how is that constructed? Because I see all the pads, the sleepers, the rails, the chair. So, in terms of how that is then constructed, what comes first? Do you lay the actual ballast? Because I suppose the
Sub ballast
is-
and ballast.
I've never heard that word before.
Ballast
Did you say ballast?
No.
No.
So yeah,
So
yeah.
you know, well, yeah.
But so how is that constructed? In what order would that be constructed? If you were constructing the structure
Actually,
of
get
the
a
rail
basic
itself,
picture.
So first it would be the ballast, as that's like the ground bit,
Uh-huh.
and then afterwards it would be the sleeper, and then you put the rail, and then afterwards you actually put the rail on, and then you would put the pad in between it, and then the chair, and then you like use rag bolts to
Clip it in.
like clip it in.
So what's a fish? So it's called.
A fish.
That's to connect the rails, because obviously you can't have one continuous.
It's
like,
fastening
two lines.
system.
Ah.
Yeah.
It's called
So
fastening.
it connects it together.
Well, good question. What is a fish plate?
A fish plate is
now, if you knew exactly what it was, you'd answer this way. So, the fish plate. If you remember yesterday, when we were talking about the single track circuit, do you remember the electricity comes into the right hand running rail, and I said that it runs a certain distance, and then we stop it going any further because we broke the rail. So how do you insulate the rails from each other? You use fish plate.
Ah.
And that fish plate is made of, used to be asbestos before it was dangerous.
Yeah.
But it's normally now made of plastic or reinforced plastic. So that current goes along.
Here in our project,
Yeah, don't
they-
tell him too much about the extent.
no, they were using the fish plate and as a temporary fixing between two rails.
Yeah.
Right.
And we got, a one fatal accident because of this fish plate.
We'll tell him about that later.
Yeah.
So that fish plate, yeah,
Some metallic.
that joins the two rails
Two
where they're
rails.
broken. Yeah. So when you break the rails to introduce what's called a signalling circuit,
Yeah.
and then you put a fish plate outside, fish plate inside, bolt it together, and then you have what's called an end joint or a piece of plastic goes there, and now the electricity gets to it, can't go any further. It's plastic. Goes over to the left-hand running rail, comes back until it gets to the fish plate and the gap on the other side, and then it comes back and creates a circuit.
It creates another question. What is the distance between the fish plates? What is the distance between the
It's
fish
about.
No, as in from one
here-
fish plate to the next fish plate.
What do you mean?
They're also using
Oh, it all
partition
depends how long you want the signalling section.
That's the.
and depends on the fish plate and the purpose of the fish
exactly.
plate.
So
Because
it's
what
just
we
the
were
signal.
using it
It's
before
the
the
signal.
de-stressing, and joining the two rails
Right.
Yeah.
through
So-
welding and
He wants to know how long is the signalling section between, The problem there is if you're using your current electricity, we use about 12 volts for signalling normally. Now 12 volts, yeah, AC or DC, if it's DC, it doesn't go very far. So you can't make your signalling system or your signalling circuit very long because the electricity just gets it and goes, I'm not going any further.
Yeah.
So you get
Not
short
very far.
distances.
Ah,
Anyway, but that's another lesson.
Okay.
Right, okay. So just quickly recap.
he will give us a detail and then the structure.
Just recap that diagram because that is an interesting diagram.
So the ballast is the bottom layer, then the sleeper, which is made out of wood,
Yeah.
is above it, and then afterwards you line the rails along parallel on the sleeper, and then you would stick it all together with the chair, fish plate, clip, and the pad.
Right. Now I'm interested as a student, and I had these type of questions when I used to do this back in 1973 when I was at the training centre. So the students are interested. I'm interested. Is that a hardwood or softwood?
My next question.
Because of
Well, the strength of the
strength and rain and it rots. So do you think it's hardwood or softwood?
I would say hard. Actually, no, I would say softwood because
Does your brother agree?
Do you agree?
No.
Aman, what do you think?
I don't know.
Well, think about it.
Do you think
Hardwood.
Hardwood, okay. I tend to agree with you. Why do you think it's hardwood and not softwood?
Because it's a train on top of it. It's soft and
Okay. But again, if you're doing physics, you could say if it's softwood, then that really absorbs more of the vibration. Okay, and if it's hardwood, then the vibration's got to crack it.
Yeah.
So if you're going down that road, but again, good. What do you reckon, Mo?
Well, exactly for the reason we just stated.
Yeah.
The hardwood would be able to absorb the actual the impact of the train,
Right.
not just for that, for the in this country in particular, the sunshine, the rain,
Yeah.
and the different climate changes that it goes through.
So in this country, because the climate could dry out wood very quickly, do we have wooden sleepers in this country? You don't know that. Do we have wooden sleepers in this country?
No, it's the
Yeah.
concrete ones, isn't it?
In this country, yes.
Some.
Yeah.
Majority of concrete ones.
Yeah.
Some.
In the old regions.
Yeah, in the old regions. But
And
most
also
most railways now
for
are
the
concrete.
temporary tracks,
Mhm.
we are using the
Well, I
wooden
saw the
one.
machine that lays the sleepers, you see, so
Yeah, it's brilliant, isn't it?
it's brilliant.
Yeah.
That should be quite good.
Right, I had all these questions when I was a youngster like you. So the answer is, technically, it is hardwood. And then the next thing is people used to say, where did it come from? Initially, that wood in the UK came from Australia, and it was Australian wood, and it was called yarrow wood. Okay? Now, if it's, what are you looking at?
It's a number of people just walking.
Oh, right, okay.
It's meant to be empty, this building.
That wood, it's wood, it gets too dry sometimes, it could catch fire perhaps. So again, before they use it, they soak it, and they soak it in creosote. So all of the sleepers in the UK are soaked in it's an oily substance,
Fire protected.
fire protected.
Yeah.
So
Yeah.
they're
But what wood? Which wood? Would you use?
well, as I say, originally it was Australian yarra wood.
Okay.
Okay, but then it became British oak to a certain extent. Really hard wood.
Yeah, it's a lot more tougher.
Quick question. I saw that one. Where's my pen? Okay. Yawn. 5 star for every time he yawns. Look, that's 8.5 today. A quick question for you. As a trainer, put your trainer's hat on. We're back here. You're down there. What could you have done with that picture?
Make it interactive.
Can't hear you.
Make it interactive.
Well, you can make it interactive. You could also
Make it bigger.
Bigger.
Larger.
could have made it bigger.
Yeah.
Okay, well done. Okay, come back. Let's see what the next one is.
There we go.
Right. So yeah, the train tracks are made up of flat-bottom steel rails that are supported by timber or pre-stressed concrete sleepers, which are then laid out on a crushed stone ballast.
That's it.
Pre-stressed concrete sleepers.
Yeah.
Yeah.
Oh yeah,
Yeah.
yeah.
Pre-stressed.
Okay.
Yeah.
Yeah. And then the train tracks aren't really made to, they're like the train tracks on normal, not really made to suit the evolution of like normal trains today, because back then trains only went about like 29 miles per hour, but nowadays it can go up to like 200. Then they can cope with it by welding the train tracks and using sleepers as a support for it instead.
Right, can I just tell a quick story here? What that is saying is that in the old days, when we first started putting these down, the length of rail that you could use was basically determined by the weight of it and how many men you had to lift it into position. So it was normally, in the old days, about 50 metres, 150 feet long, okay? And in America, it was all done by Chinese labourers. So you'd have Chinese labourers lifting it up, and they would put it down onto those wooden sleepers. On the sleepers, you've got the metal chair, so it sits in the metal chair, and then between the chair and the rail, there's a gap. And that allows for the rail, if it gets hot, to slightly expand,
Yeah.
and then in the evening to get
Contract.
colder.
Yeah,
So,
expansion
so
joint.
to stop the track from wobbling in the chair, they put in a block of wood, and it was just called a block. And every day and every night, someone would walk along the track with a big hammer, and he would just look down, pick up the wooden block, because it gets cold at night, so it shrinks, falls out. So his job every night was to go along, pick up the wooden block, bang. And they used to do that on London Underground when I was a driver in '75.
Wow.
Okay. Nowadays they've replaced them with what's called pandrol clips. So they're elasticated steel, pre-stressed, and they are put in the gap. And as the rail gets hotter, okay, expand, and as it gets colder, they contract. They don't fall out. So the old wooden blocks have been replaced with these steel clips. Right. Interesting. Now the next thing to tell you on that, what you've sold us there, is that used to be laid, as I say, in about 150 foot lengths. But nowadays they've got an actual machine, yeah, that runs along the track, and on it is a long piece of rail, maybe 1 kilometre long, and it lays it into, men help it go into the chairs, and then instead of putting in a fish plate to connect it with bolts, they stretch it. So they lay it down and then they actually stretch the rail, and then they put another piece and they weld it together, flash weld it.
Yeah. Flash butt welding.
It's called flash butt welding, and they weld it together. So now, and that's what we do out here on this railway.
Later they are doing this
So
de-stressing.
you may find out there that there's a length of rail which is 2.5 kilometres long.
Right.
Here we have around, I think, 250 meter in our.
And they stretch it, and they stretch it, and they stretch it, and then they weld it. So those rails out there every day expand and contract, but they don't break. So that's where it's saying they're not necessarily suiting the evolution of trains. Good one. Next one.
I think if you put it on that,
So they used to have jointed rails because there was no alternative. However, it wasn't really financially effective because it always needed lubricating for it to like stay stable. And then on top of that, it also needed heavy maintenance a lot to prevent geometrical defects in the
I
joint.
suppose because of the environment, they actually made it drier.
Yeah.
I suppose hence why they needed
So, yeah. And then because of the geometrical defect and the heavy maintenance, that's why we need it.
Yeah. So when they're talking geometric, they're talking about heat conditions. Okay. Oh, interesting. Okay. Good. Anything else?
No, that's it. Next thing
That's
is
sleepers.
Did you happen to read what they call sleepers in America? Because they don't call them sleepers in America. No, they're called ties. They call them a tie.
Tired.
A tie. T-I-E. Like a tie. Yeah? The Americans, you know, we call, in here we've got things called switches and crossovers, yeah? In English we call them points. They were called points. And the Americans call it a switchover. Okay.
Yeah, switches and
switches
turnouts
and turnouts. We don't call them turnouts. They call
See,
points.
do you remember on the way to Medina, you saw the actual railway line, we drove past it.
I was asleep.
Okay. In any case, you would have seen the sleeper, not the ballast there, because you can actually see it moving in the desert.
There
You
are
actually see the ballast and the actual.
there are two types of tracks mainly. One is called ballasted track, and another is called slab track.
And the slab track is where it's as you're approaching the
Yeah,
station, right?
Yeah.
And also, and I think you're going to talk about this because you mentioned it downstairs. In this country, you get a lot of high winds, you get a lot of sand.
Sand.
And if the sand gets blown into the ballast,
It's contaminated.
it's what we call contaminated ballast, and it makes it difficult. And it's because the ballast, when you put the ballast together, it's tamped.
Yeah.
You put a machine into it and you agitate it like this, so that all the little boulders join together, and it's like dry concrete. So that's what tamping is. So they shake it, and it becomes solid. Now, if you get the sand blown in it, the sand particles get between the boulders and they push it apart. Okay, and that means that you have to go out and do the maintenance and do more tamping all the time because the sand is blown into the ballast.
Dune sand they are calling.
Yeah. So therefore, if you've got an area, as we have, which is prone to sand drifts, the wind blows the sand onto the railways, and we know exactly where that is, then what we do is we put in slab tracks, and we put all of our track as concrete, so that the sand can't blow in the ballast.
Oh, interesting.
And so we've got slab tracked areas where there is specific
Wind.
sand blowing the wind will blow.
direction, because of the geometry.
That's why you have slab track.
Interesting.
Embedded track, pit track.
Big track, yes.
Interesting.
See, it's interesting. See,
Very
things
much
to
so.
learn, isn't it?
Yeah, very much so.
Okay, what are you going to tell us about sleepers or the ties?
Very cool. That was quite nice.
You know, so the bit of the main support material and then in between the valves and the actual rails.
Okay.
And then the most of them are made out of wood, and then how the newer rails are use steel, which is apparently false now. That's what it said on the
Pre-stressed concrete.
pre-stressed concrete and stuff.
Yeah.
And then the purpose is to help support the rails and keep the rails straight and parallel. And then, they were made out of wood because they provide a resilient track with excellent dynamic attenuation. And they also are very effective in noise and vibration reduction. However, it was proved that pre-stressed concrete, except was better than wood, so it got replaced with other materials instead. Because they could be expensive. Since the discovery of a lot of iron ore in the Cleveland mine in 1850, which I talked about yesterday as well. Yeah. And it was used first in Australia in the 1890s.
Yeah, I know.
Okay, that's brilliant. Excellent. I'm interested now. Okay, we've got the tracks, Aman. Yeah.
Yeah.
And what rolls and runs along the tracks? The train. Yeah. What part of the train rolls on the track, on the rails?
That rolls.
Yeah. What rolls on the rails?
What do you call it then?
The round things.
Yeah, the wheels.
Excellent. Why don't the wheels? Why don't they fall off the track? Because it's very difficult steering these trains, I tell you, especially at 300 kilometres an hour.
Is it because
So how does the wheel stay on the track?
special made wheels so that they curve inwards?
Go on, explain more.
To the rail, and then when you move, it just follows the rail's path.
Mo, do you know it? Does it? How's it stay on?
As I guess, I would say, well, as you said before, with the wheels that are specially designed for the track itself, they have other arms connecting to the wheel, and it's all interconnected, which follows the path. I'm not particularly familiar with it, but as a guess, with the sophistication of the actual wheels itself and the suspension,
Come on.
it allows it to actually grip onto the rail itself to move along the track.
Okay. So the wheel is like that. Okay.
Wow.
So that's the wheel. Yeah. And that's the outside,
Mm-hmm.
and then that's the inside, and so you've got a flange.
Yeah.
So you've got a scalloped flange. Okay. And that stays on the rail.
Ah, right.
So-
So that's the guide, essentially.
It's so yeah. So you've got the weight of the train, which is about 300 tons, pushing on the wheels. The wheels are scalloped like that. So you've got a face and a flange, and that flange is on the inside of the rails.
Right.
Okay. So the train physically can't
Move
fall
out.
off because the wheel is technically lower on the inside. Yeah. And it can't fall off.
It's all connected together. Yeah. Let's go.
Right, he wants you, does he? Okay. Right, carry on. Let's finish off.
Continue.
You're going to get the rest of this tonight at
I
home.
will do. I can continue recording because I'll be.
Oh, are you recording the most?
Yeah, it's recorded.
Are you recording?
It's always recorded and in the past few days.
Okay, carry on. What's the next bit?
It's good.
Ballast.
Next one is the ballast.
Speak up a little bit about it. Yeah, yeah.
Next one is the ballast. Oh wait, it's got a picture on that.
Don't worry.
Yeah, they're basically the multiple like little rocks that are underneath the rails and the sleepers, and then they're to support the rails too. And then it helps by keeping the sleepers still, because they surround the sleepers.
Yeah.
Like kind of be just underneath the rails, so they don't interfere with the train. And then still, and also since there's gaps in between the rocks, it helps the sound and vibrations get through easy, which puts less of a strain on sleepers.
Stop there a second. Let me just tell you. If you go onto YouTube and if you type in YouTube and say bouncing rails on railways, what you'll find is that the ballast it absorbs vibration.
Yeah.
So you can actually see lots of trains on YouTube, and especially in India, Pakistan, unfortunately. The ballast is old and hasn't been tamped,
Yeah.
and so the train sort of you see it sort of bounce up and down the rail, and you see the rail going into the soil like this,
Yeah.
Okay.
And then it's crash.
and that's simply
Derail and crash
and then they crash. So that's where you get what we call bouncing railroads, and that's because they haven't tamped ballast for a period.
The purpose of the ballast is to absorb
The
the
vibration,
the
and
vibration.
vibration, and
Noise.
noise. So if you're interested, just YouTube it 2 seconds, and these clips are all there on YouTube. Okay, next one.
And it also helps if a load of water, if some reason falls onto the train track, because it just sinks down.
Yeah.
And then
So if it's
Rains.
raining, the rain just goes down, goes through the ballast. Yeah, it doesn't sit on the wooden sleeper if it's wood, and it doesn't rot the wood. And also, if there's gaps in the ballast, then you're not going to get seeds from plants that are going to grow in there because there's no technical soil.
Yeah.
So these are all good reasons for ballast. Excellent. Yeah.
And then it's also for vegetation because it can just sink again.
That's right. It sinks and gets lost.
Yeah. So, and the word ballast actually comes from a nautical term that's used to stabilize a ship with rocks. So
So when it anchors down, you know what it means.
what?
The nautical term.
Initially, yeah. So, because I'm a sailor, so when people started using ships and little boats, and it's made of wood, okay, and so it wobbles like this in a wave. So what people did initially was they put old rocks in the bottom of the boat, okay, and so you put weight in the bottom of the boat, and so that stabilises it and stops it rocking so much. Nowadays we don't have rocks in the bottom of boats. We have a piece of metal called a keel.
Yeah.
So you have a big piece of metal on the boat, hanging in the middle at the bottom, called a keel, and that stops it wobbling and rolling. So that word for stones in boats was called ballast. So they just borrowed the same word from the nauticals when they developed it. Good?
And then it's actually imperative to maintain the ballast because if you don't, then it will eventually become degraded, like you said earlier.
Yeah.
And then which makes it then not be able to drain like all the things that can come down like vegetation and rain. And then which there's something actually underneath the ballast called the subballast, which is a bit thinner than the ballast.
The ballast.
It's a little bit smaller stones, isn't it?
Yeah, it's just smaller stones on a thinner line.
Yeah.
Compacted with the.
Yeah, so you start off with a bed of very small stones, and you compact it, and then you put the bigger stones on.
Which
Okay,
is
so that gives you a
loose.
firm base.
And then,
Okay, what we call a sub-ballast, and
yeah, and I think if I remember right, the subballast is around 50 centimeters thick,
that's right.
Yeah.
and then the actual ballast itself is around
30, 45, isn't it?
I thought it was 150.
Yeah, 100 more than this.
Oh, you're talking centimetres, yeah.
Yeah, centimetres.
You're talking millimetres, I'm talking centimetres. Yeah, that's right. So he's even got the size of the stones as well.
Yeah.
Brilliant, well done.
And then and then the subballast will have to suck up the debris that's coming from it, and which degrades that as well.
Yes.
So eventually, if it keeps going on without being replaced or fixed, then the train will just fall.
What did they use to maintain the ballast?
They just take out the stones and replace them with more.
What they do is this. We have a machine called a tamping machine. It looks like a big old locomotive, and then it goes along very slowly. And as it goes along, it's got these arms that prod like this. And as it goes along, it will prod into the ballast. Train stops. It shakes up and down. So all the rocks, all the ballast around it resettles.
Okay.
Okay. Then it pulls them up, and it goes along again. Stops. Puts the arms in.
Yeah.
And it's called a tamping machine. They call that tamping. And that's how you maintain the ballast. That happens every night out there on our railway where we've got ballast. Yeah. We've got 500 kilometres.
Yeah.
And then we've got that on the upside and on the downside. So we've got 1,000 kilometres of track. So we've got a lot of ballast. And you'll see it when you get on the train. Okay. Interesting.
Oh, that's the picture.
There it
They
is.
should have it first, because it actually shows the ballast, the subballast, and then
Yeah, so the sub-ballast is the red, isn't it?
yeah.
And then the blue is the ballast.
Yeah, and then the pink. It actually says it here, but I can't read it.
Yeah.
I can read it there if you want.
That's okay. We've just talked about it.
Yeah. Oh yeah, this is 7 facts that I'm.
Oh, right, okay. Right, so that's, stop a minute. So that was ballast. You learned quite a lot there.
Yeah, that was a lot, yeah.
I remember when
I've never known, like, because I've seen the ballast and I knew it was there.
you know the stones are there, but
Yeah.
you're not sure what they're there for.
Yeah, I was
Yeah,
like, I was thinking it did probably support the rails and stuff, but like you said, like it stops the rain and it grows vegetation and what's it called?
And it absorbs vibration
Absorbs
and it
vibration.
absorbs noise.
Yeah.
So Dan, you know, no, that was excellent. Okay,
Yeah.
so what facts you got for us today?
Oh. That's
These are things that you don't even think about, do you? Really?
Yeah.
Until someone stops and makes it interesting for you.
Yeah.
Yeah, first thing,
Yeah.
an Indian girl in India got beaten to death by an extended family, and it's for a pretty stupid reason. She got beaten to death for wearing a pair of jeans. Yeah.
You read that.
And then the extended family told her mother that they were taken to the hospital, but then they actually just dumped her in the river. And then that's just like that.
There's nothing you can say about that. I mean, that's just wicked.
Yeah.
Yeah.
What causes that?
I don't know.
Yes,
Just
you
like
did.
they
Why did they do that?
It didn't say a specific reason. They just said because they haven't like discovered everything yet. The case is still going on.
Why do you think they don't like her wearing jeans?
It's a cultural issue.
Thank you.
Yeah.
It's a naughty, nasty, cultural, religious, bloody thing, isn't it? And so we won't talk about religion. That's what's done that. Dreadful. Okay, next one.
So researchers found satellite photos of what is presumed to be a Chinese missile silo that is under construction currently.
Oh. Where, obviously, if it's a Chinese satellite,
Yeah.
I suppose they found it in China, did they?
Yeah, it's like if I remember right, I think it's around northwest China, like northwest region.
What's a silo? What's a missile silo?
It's basically just like it's like a place where it's like a shoot on the site thing. So it's basically just like a restricted place where not where only people who are allowed to go into.
It's a tall shuttle, isn't it?
Yeah. Okay, so it's slightly bigger than the rocket itself,
Yeah.
and then it's dug into the ground, isn't it?
Yeah.
And then they put the rocket in it, and then they put a cover over it which opens. And that is technically, that's a silo. And that device called a silo, they make them in metal in America and other countries, and that's where you fill up with water or flour or corn, yeah, or cement, and then you open the bottom and it all pops out. So that's a silo. Okay, so they found one of those, have they?
Yeah.
Through satellite photos.
Yeah, researchers just found
Those Chinese, they're cunning bastards, aren't they? Cunning bastards.
They try and catch
We all do it. There's silos in the UK as well. You just don't know where they are.
Yeah. I think there's a lot of in the islands as well, aren't there?
Exactly. All right, so they found another one. What's the next one? Dubai.
And then Dubai, you know how they've had man-made islands?
Yes. Yeah.
Yeah, they've actually had this mega project that's been going on for 2 decades.
Yeah.
It's called the Heart of Europe, and then it's nearing completion. And it's just like a whole one. It's like the Canary Islands, but like the islands are doubled and they're man-made.
Right. So
It's a resort. It's an island resort where there's multiple islands, and that's just doing.
have you been to Dubai yet?
No, my dad has, but we haven't.
You've got to go.
Yeah.
I told your father the other day. As soon as they lift these COVID flighty things, it's an hour and a half away.
Yeah.
Well, it's a bit more than that from here, about 2 hours. I lived there for 10 years. Yeah? Have you heard of an expression where they say it's the dog's bollocks?
No.
No? The mutts nuts? The dog's danglers? These are all London expressions for it is bloody good.
Yeah.
Okay? So, Dubai is the dog's bollocks. It is the best place here, honestly. And they've got islands there made from sand. So what they're saying here is that one is being near completion.
Yeah, no, it's like a whole bunch of islands, so it's multiple.
Yeah. There's I lived on one. It's called the Palm.
Yeah.
Palm Jumeirah. I used to live there.
Yeah.
Anyway, get your dad to take it. Another question for you.
Yeah.
It says up there. What does it say? In
What? Mega project?
how long does it say?
2 decades.
It says
2 decades.
Yeah,
Yeah.
2 decades. So 20
Yeah.
years.
How long is a decade?
10 years.
You agree? So a decade is 10 years. Yeah.
Yeah, decades and
Yeah.
centuries.
How long is a generation?
It's a century.
No, 30.
It's between 25 and 30. They classify generation as sons then having their own children. So a generation is between 25 and 30 years. A lot of people don't know that, you know.
Yeah.
Surprising, is it? Okay, brilliant. So I didn't know that they were going to finish that, but it is finishing.
Yeah.
Next one.
And then a fish that is immune to piranhas is called freshwater fish.
Yeah.
It was saved from extinction recently, and then it was one of the largest ones that I've ever found in the Amazon River Basin. And then it's 10 feet long and it weighs almost 500 pounds.
Christ, that's that. That is a big fish.
And there's actually a picture of someone holding it, so someone could,
Have two people holding it.
It says,
It is said to have a bulletproof skin.
Yeah, bulletproof skin.
And to breathe air.
It can breathe air, and it can go 1 day without water. So it can breathe.
And that's a fish.
That's a fish.
Yeah, that's a fish.
Usually takes.
Now I'm going to Google that later because I'm interested to find out
It's
more
on
about that.
It's on CNN. Just go on CNN and then type it, and then just scroll all the way down.
It was on, well, as you know, I look at CNN and the BBC when I have my lunch shortly. So hang on a minute, stay with that one. I can't believe it can spend a day out of water.
Yeah, because usually takes.
Because it's got gills,
It
isn't
can-
it?
Yeah,
That's what they used to breathe.
That's what makes it spicy. It's like a superhuman fish.
What? It says there piranha is a freshwater fish, isn't it?
Yeah, it's called freshwater fish, and it's immune to piranhas because it has a bulletproof skin. So and then piranhas can't really bite through it.
What's unusual about a piranha fish? Any idea?
There's a teeth.
That's
isn't it?
Like a frog.
It eats you live. So you never swim near piranhas. They've got huge teeth. They're only about this big,
Yeah.
but they all swim around in shoals.
Yeah.
And if you're in there, they will just come and eat you. And once they've got hold of you, you can't get rid of them. Nasty fish, piranhas.
Wait, Aman, did Musa have to go over a pool of piranhas? It was like year 6 and then there was like a school, it was a school trip. I don't remember what it's
The
called.
little adventure trips you have. It's like little piranhas and they went down.
Yeah, they're like little
Yeah.
walked over a pool.
So they just walked over it. But I don't think it was that dangerous.
There, when I was in Dubai, living there's one of like a fun fair place you can go to and a swimming pool. And what you do is you pay 10 SAR and you go and put your feet in a very small